as you may have noticed on Facebook, I said that there was going to be a short stream today, and I plan on sticking to that. Um, one, because I do have something I'm doing at 9. It's a fantasy draft I have to focus on, but at the same time, my voice is actually pretty harsh right now. I took some throat lozenges, so it's cleared up a little bit for the stream, but um, my throat has been raw ever since I went to the UCF football game where I was screaming all day because we won. Um, so I'm just gonna get right into it. So let me switch the screen here so you can see what I'm talking about. I have forgotten to do that in the past. Okay, so you're gonna see a lot on the screen, but it's a little bit less than last time actually because I don't have the AI running. The reason I don't have the AI running is actually because it's done, and so you may think, "What do you mean done?" But it's legitimately done. Um, so what I'm gonna go through is just what all this means. So I have obviously the gen number is the generation that the AI is on when these best scores have been achieved. So first off, we have Gen 1. That's obviously right off the start. We have the original null values, the original null value equations. This is what we expect because in the first generation, actually, it can technically mutate before this is posted to the first generation, but um, it was not fast enough, or I guess all of the equations were exactly the same as the one you see here. And this is something that I fixed um, previously, and actually I was attempting to run on the previous stream, but I had to fix that because there was an error with it. It was pretty simple. I was just missing a bracket with an I in it, and so it was kind of hard to see, but I figured it out. So we're just going to scroll down here. We see Gen 3. We have a new best. So this means that it mutated and it has now achieved a better score. Now remember, this is lower scores because it's attempting to converge on an answer. So we want it to get down to 0 if at all possible. So we have Gen 4, the second upgraded to the exact same thing. Gen 8, the best upgraded to 3, which is actually somewhat significant because 3 is involved in the equation. But it could just be random at this point. So it's pretty consistent that it's the second is grabbing hold of it, and that's actually something I mentioned up here. Is I'm considering adding in a best to second diversity filter, which means that the second can't have the exact same DNA as the first, as the best score. This wasn't a problem in the ball drop just because there were so many possible numbers to mutate. But when you only have one in this case, or even just 5, or even 10, it's very easy to have an exact same DNA set. So that's something I'm considering. I'm not actually sure if I want to do that because obviously, if it's a very good equation, then you want as much possibility as you can of propagating those traits onto the next generation. So then it took a little bit more time because these were sort of the average score that programs were or that DNA sets were achieving. So we see 14. It got a little bit better, so the second upgraded. This was when it became the same. And here in generation 30, we actually have a big jump. So this is very significant, this equation right here, because first off, I should draw out what these equations are. So I want to just show you what the actual equation this AI is attempting to achieve is. So the way that I wrote it is x1 plus x2 minus x3 all times x4. And so the order of these is insignificant because it is the exact same chance to randomly choose any of these variables out of the 9. Now, you will point out that there is not 9 variables showing. Now, this is significant because in a real-world situation, there will be dummy variables. There will be variables that aren't important, or they can be represented by other variables in a more efficient manner. So this is significant because it shows that the AI can pick out which variables are necessary and apply them in the correct orientation. So, but what I want to point out is this part right here, this x times 4. And also, I want to also mention that when you're looking at the equations over here, they are going to be the only order of operations is dictated by parentheses. So you have to keep that in mind. Um, but this isn't a case right now because it's not compound enough. Um, but okay, so we have this is the equation that the AI is trying to get to. But you will notice that x4 is multiplied by this large number here. And well, it doesn't necessarily have to be large, but x4 is multiplying by it, which, if you know anything about convergence or divergence or multiplication, um, is much more significant than regular adding and subtracting. So this means that this x4 being multiplied by a number is very important in creating new equations that are more like the equation we're seeing here. And I can see that it's a little bit under my picture, but I think you can see it. That's x4. Sorry about that. So um, let me just get this down. Okay. So um, actually, I can continue with the equation list. So we're going to keep scrolling down here, and you will see at generation 30, this is a long time. So what happens when there's a long time between new bests? The stuck value gets higher and higher. And this actually was 16 or 15 or around that. So um, this meant that it was very close to killing off the second parent. This wouldn't have been a big deal because x3 was both equations, so that probably would have been beneficial. But it did randomly mutate these two equations. It is coincidence that they both mutated at the exact same time, but it is not. There is something to that because it was such a high stuck value, there was a very high chance of mutation. And also, in this run, I also adjusted the mutation so that it is there's a 30% chance just at the beginning that the AI will mutate. This chance increases as the stuck value increases. So yeah, so um, this other note, I'll just get this out of the way. Oh, actually, I'll talk about this one. So the 3 compound layers per mutation, this means that if you will remember from the previous stream, I mentioned that I made it so that the AI did not have free reign on how long of an equation it could make. It could only add one layer onto the equation at a time. This was a good idea because it made it so that the AI ran faster and meticulously approached the convergent point, as opposed to flailing around and just shooting in the dark with every infinite possibility. But this was not enough because in the previous running, um, the AI did not converge very fast at all. So you saw a little bit of that on the stream, but I decided that I would give it a little bit more free reign because maybe the each piece isn't significant, but the entire piece is. So having that ability to jump to a conclusion is kind of important. I didn't see much of that, but I did see this mutation into a compound variable. So we have this compound variable, and it is very lucky because it has the most significant variable in the game. So this x4 is important because it's being multiplied by everything else. This other equation is also kind of nice because we see that it is x2 and x2. x2 is involved in the original equation, as you will see from the paint window. So then here we see that it became the same equation. This has been a common theme. And now here it actually got better, and I think what happened was that the AI, you will see that this number is more than 20. So the um, the second was killed and then replaced by the exact same equation. Okay, so here it becomes slightly more significant. Now, x9 is not that important, but having a more compound equation is. And so that's important because it's important to grow the equation so that the correct variables can be put in place, as seen um, in the paint window. And so we will continue down. The second actually compounded and then slightly mutated. I believe it took the exact equation as the best and then mutated, and then it took over the best, but then the best became the second. So we'll continue down. Now, this is a very significant equation right here because x1 minus x3 is part of our equation that we have right here. X1 is being subtracted by x3. Now, if you think about it, x1 plus x2 minus x3 is the exact same if you don't have the parentheses here. So these parentheses do not matter. The order doesn't matter. X1 minus x3 times x4 is significantly better than the previous situation. So this is a very good equation, and you will see that in 3 generations it actually removed the extra variable that was unimportant. So now this is almost spot on. You will see that the score is still pretty high, but this is the best score that anything has achieved up to this point in any of the runnings. So this will continue, and so it's getting a little bit better by, well, it actually just put the exact same equation in. And then here we see this number. Now, if you know anything about scientific notation, that is 6.46 times 10 to the negative 25. And so the reason that this is actually not 0 is only because it did them in a different order. And computers, if you know about how bits work, are not exact in their floating point decimals. So the way that this wrote the way that the AI wrote the equation out is essentially, I'm just going to write the numbers to make it quicker as opposed to writing the brackets and the x. So you will see that the equation is 4 times the quantity, that's a multiplication, the quantity 1 minus 3. And I believe that this is all added to, because of the order of operations for how this is working out, essentially this is what's happening. This is multiplying by 2 times 4. So if you factor this and bring the 4 out to the front, it is 1 plus 2 minus 3 all times 4. And that's our equation. And so, like I said, because it did this over here, there was an extra operation, and that's where the error is occurring. Because the error that the original equation had was different from the error that this equation has. But you can see that it's not very big at all. So that is very significant in my eyes. I'm extremely happy with how this is working out. I do have some ideas for how I can possibly make this a little bit better and so it can go faster. So this is what I've been talking about up here, these considerations. But this is pretty significant because it actually achieved the full equation that I was hoping for. I did want to point out, so this is 85 generations. This may sound like a small number, this may sound like a big number, but let me give some perspective. So I'm going to clear the paint window here so I can get a little more space. And so I did some simple sampling. This is very approximate. It could be slightly wrong, but um, what I did was I timed how long it took for a generation to go through. I actually timed how long it took for 5 child um, DNA sets to be analyzed, which is a very small sample, and so it may not be the most accurate, but it actually gave me a pretty nice number, so I rolled with it. It said that each child took 1.504 seconds. And so we can claim that's just 1.5 because the zero point zero 0.04 isn't too significant. So this is, there are 100 children, so that means 150 seconds per generation. And it took 85 generations. So this is 850 plus 425 equals, that is 1200 plus 75, 1275. Um, that is how many seconds it took. And um, so then you can do the math in order to um, bring this down to hours, but it actually, I may actually have that wrong. I'm not sure. I did the math earlier, but it brought it out to essentially adding up to completely to about 3.5 hours. So this is a lot of time, but in terms of some analysis, especially in previous generations of the human race, 3.5 hours isn't that long. That can be achieved in a day. And so if you were attempting to figure it out on your own, you could just let this run in the background, and possibly it would figure it out before you even could figure out what the equation was yourself. Um, so now this was a very easy equation to learn. I did this on purpose because I wanted to see if the AI would work. I do have a more significant equation, which I've talked about on previous streams, that I will eventually be using, but I do want to mess around with some of the considerations that I had at the top of the notepad here. I'm going to use this running as a benchmark, and so scientifically speaking, I should technically run this a couple more times and see what the average is. I may be doing that in my off time, just if I have my computer on and nothing else to do. But this essentially is the benchmark, 85 generations. So I want to see if I can slim that down. I don't know if I necessarily have a goal. I just want to see if it can be done. And I think that these filters may actually help in doing so. They may be malicious also. So it's something that I'm kind of just guessing checking with, but that's essentially what I'm going with. That's pretty much the whole talk for the AI. I see we have a couple people in the chat. If you have any questions, please let me know while I'm rambling on at the end here. I have a couple more notes. One, I posted on Facebook about this, but I actually did storyboard out the next episode of my comic, The Theoretical Superhero Coalition. So I will be working on that soon. And also, I'm thinking about something that just on a software level, it kind of makes my life easier. But I haven't been able to see if the play ad button is actually playing an ad. So what I think I'm going to do is I believe that if the ads are enabled when people enter the stream, they are provided an ad, and then that's it. I don't get too much revenue off of the stream, so I'm thinking for just to make things more smooth in transitions, I am going to pause a little bit between sections in the Saturday streams, but I will be not. I don't plan on having those big 45-second to a minute breaks. I think I'm going to just roll through and then add in the ads later because YouTube still lets me do that accurately. So I'm sure that will be something that everyone will enjoy because I won't be randomly clicking the ad button, and if you don't get an ad, then it's just awkward silence with me. And I know how people love that. So that's pretty much all I wanted to talk about. I'm not seeing any questions in the chat, but I am planning on streaming on Saturday, I believe. I do have something I might be going to on Sunday, so I haven't figured that out. But I do think that I will be streaming on Saturday, so you can look forward to that. And But other than that, that's pretty much all I wanted to talk about. My voice is starting to hurt. Oh, my throat is starting to hurt a little bit. So I am going to be signing off here. But I want to thank you guys for watching. If you're watching live, if you're watching later, then head over to my channel. There's a lot more videos for you to check out. I think I'm up into over 150 now. Some of them are pretty long, but some of them are short and sweet. So you might want to check them out. But other than that, I want to thank you guys for watching once again, and I will see you on Saturday.